All right, let's start to this lesson. Well, this lesson. And let's take a little bit of a step back and see what we've done so far and where we are at right now, because we just finished the topic of inequalities. So we're still in algebra, sequences, and series. We already did the algebra topic. We already did the quadratics topic. We just finished the inequalities topic. And now we're on to surds. Surds, indices, and logarithms. Right? This is where we're at right now. Right? This is where we're at right now. Logarithms. And the next one after is going to be sequence and series. So we are almost finished with this topic. Well, this section here, this section. Okay, so let's start off with surds. And today's lesson, this lesson is going to be about surd operations. So just put that surd operations. And the objective from the syllabus is to perform operations involving surds. Right, so we're going to perform operations involving surds. Now, in some of the lessons that we did so far, we encountered answers that involved a lot of square roots. And now we're going to learn how to work with those square roots properly. This is because you're going to find this happening a lot. You're going to find it coming up in trigonometry. You're going to find it solving some quadratics. Whenever things don't work out exactly, you would find surds comes into play in some places. And some of the answers that you have to state later on is required that you know how to deal with surds. All right. So all I want you to do is think of surds as if you were thinking about x when we did algebra. Right? You'll find it much easier to understand how to perform the operations if you think like that. The first thing we want to do now is go with a definition. Right? Everything starts with a definition, so let's start with a definition. So we're going to define definition. You know what? Let me type this out because it's just going to be words, and I type faster than I actually write. So let's put here definition. And we're going to say that a surd is an irrational number that is the root of a rational number, right? And let's give some example of that statement. Okay, example, if I have 2, which is rational, then the root of 2 is irrational. I spelled that wrong. Irrational. Right? The root of 2 is irrational. Why is it irrational? It is irrational because this, we just write different color. This cannot be simplified into a fraction, right? This cannot be simplified into a fraction. The number that you have underneath the square root is called a radicand, which we'll refer to it later on, right? Just remember it is the number in the root, right? So it's the number in the root. All right, so now that we have a definition for the surd, let's go and start looking at some of the properties, and we'll solve problems involving those properties as we move along. All right, so let's look at properties. right? And first property that we're going to start looking at is addition and subtraction. So addition slash subtraction. I should really start typing out. The first one that we're going to look at is the root of a plus or minus. You know what? Just put plus. Yeah, plus or minus the root of a is going to give us the 2 root a. Now this is what I mean by think about it in terms of x, right? Think about it in terms of x. So if this here is x plus or minus x, it's going to be, you know, yeah, do this up. Okay. So if this is x plus x, I erased it because minus root of a minus root of a is just going to be 0, not 2a, root a. Anyway, so x plus x is going to be equal to 2x. This is what I mean by just simply think of the surds as algebra's x. All right. So if it is that we do in addition, we're going to get something like that. And obviously, similarly, if we do something like a minus root of a, it's just like how it's going to be. We're going to get here 0. Okay. And let's look at another one. What about if in the case that, let's say we have root of a, some number, plus or minus the root of some other number, then we don't have anything to change, right? Just like we would have something like x plus or minus y, whatever, x plus y, x minus y, it'll stay the same, it won't change. Okay, so let's look at an example for this one. Let me just put this maybe in orange, right? Let's look at an example for this one. Let's say, for instance, we have root of, let me just write that differently. Let's say 3, root of 3 plus 2 root of 3. And that is going to be 2 root of 3, right? Remember, we're just thinking of it as x. So in other words, if we have another example, and we say 4 root of 2 and minus root of 2, it's just going to be 3 root of 2. Okay? And if it is that we have, and let's go with another example, if it is that we have another example and we say root of 3 plus or minus the root of 2, it's just going to remain the same, right? You know what? Maybe it is I should actually move these examples a little bit, right? Let's move these examples a little bit. So let's take this over here, move this over there, and then take this, move this up here, right? So that's for that one. Let's take this one, move it with a minus sign down here. Let's take this one and move it over here, right? So that is addition and subtraction. So far, so good. Very easy. We just remember our algebra. Let's go on to multiplication now, right? So multiplication. So multiplication is a times b root of that. This rule is very simple. If you have something multiplied by something else, then you're able to split those somethings together, right? You're able to split them or join them together. So root of a multiplied by root of b. And again, let's do a quick example. Say, for example, we have the root of 45. Now, instead of going to a calculator, let's say you want a more exact answer, right? Let's say you want a more exact answer. What you're going to do is you're going to use this multiplication rule. You're going to say that this is the same as saying the root of 9 times 5. Why 9 times 5? Why not 1 by 45? Because 9 here is a perfect square. Perfect square. Right? So we can square root that and we can get a whole number. So that's why we'll separate it like that. Whenever you're separating it, try to separate it into factors where you can square root one of the factors at least. Right? Now, this here becomes, I should really change the color on this here. And change this one here to yellow. No, an orange, pink. Right, pink. Right, so let's do this one here. And we have that. It's going to be equal to the root of 9 times the root of 5. And we already know that the root of 9 is 3, so you're going to get 3 times the root of 5. And this here is usually written, reduced and written to 3 root of 5. So it's understood that there's a multiplication inside there, just like how we would do it with algebra, where we would say, oh, 3 times x. Then it's 3x. It means 3 multiplied by x, right? Again, think of it like algebra and it'll be easy for you to understand, right? So that is multiplication. let's look at now division and basically rationalization as one. So division slash rationalization. No, let's do the division first. All right, we'll separate that property. Okay, so let's do the division property. And the division property is that if I have a number divided by another number and I have the root of that, it is equivalent to that number, the square root of it, divided by the square root of that other number. All right, so that means if I want to do an example, and I say I have 27 divided by 8, and I say square root of that answer, then that means I'm going to have 27, the square root of that, divided by the square root of 8. And then remember, I can use the product rule that I just had, the property for multiplication. I can use that property and split this up a little bit, because 9 by 3 is 27, and then 4 by 2 is 8. And 9 and 4 are perfect squares, so I can just simply say 9 times 3 square root of that divided by 4 times 2 square root of that. Now, it's my habit to put the perfect squares closer out to the front, so that when I square root that answer, I'm going to be able to simplify it easier, and you can see exactly where something goes. So like root of 9 times the root of 3 divided by the root of 4 times the root of 2. And this becomes 3 root of 3 divided by 2 root of 2. Now, at this point, you would say, okay, I'm done. No, that's not the case. You cannot have a denominator with a surd, right? You cannot have a surd denominator, right? So surds should always be in its simplest form, right? Simplest form means I would take this and I reduce it to this. But that is not the end of the simplest form, right? Surds should not, and I just put a capital on this one, so not appear in the denominator, right? So it's not going to appear in the denominator. We can't have that appear in the denominator. And this is, to deal with this, what we'll do is we'll do something called rationalization. Rationalization of surds, right? We're going to do something called rationalization. And this is nothing more than learning how to multiply by 1, right? It's nothing more than learning how to multiply by 1. So we're going to take this here. Rationalization is the removal of surd from the denominator. Right, we're going to remove the surd from the denominator, and we're going to have here, let's start off the example here that we stopped with before. That's not finished, so let's finish it. So the example that we're going to continue is 3 root of 3 divided by 2 root of 2. Okay. And what we're going to do is we're going to multiply this by a convenient form of 1. A convenient form of 1 is any form of 1 that allows you to change the form of something but not change it. Okay, so we're changing the form of it, we're not changing it. So let's see what we have here. With this, we can have something like this. 3 root of 3 divided by 2 root of 2. I can simply multiply by root of 2 over root of 2. Root of 2 over root of 2 is 1. And I'm multiplying by the root of 2 because I know if I multiply by the root of 2 on the bottom here, these two here will multiply by each other and I will get 2. So if I multiply the top, I'm going to get 3 root of 3 times root of 2 divided by 2 root of 2 times root of 2. Now I'm going to use the product rule that we just talked about earlier, the multiplication, and I'm going to combine these together. Right, I'm going to combine these together, and I will end up with something that looks like 3 times root of 3 times 2 divided by 2 times 2 times 2 root of that. This here means that I have 3 times the root of 6. This on the underneath here times it's going to be 2. And then 2 by 2 is 4 here. Root of 4 is 2. So this here is multiplied by 2. So this becomes 4. And this here is my final answer. This is the simplest form. Right? This is my simplest form. Right? No surds in the denominator, simplest form. Okay? And that's it. That's all you have to learn about surds. Okay? Let me just start doing some examples now. And with the examples, you should be able to get a better understanding of how to do this. Right? You know what? Before I do that, let me just do one more of this rationalization of surds. Now, this is one of the ways that you can get this rationalization of a surd. Another way that you can do the rationalization is something that looks like maybe like this. Root of 3 plus 2. All right. Now notice we have here a root of 3. We have the 2. But you cannot, and I'm saying it again, and I'm going to write it in red. You cannot multiply, and I'm going to write it a little bit bigger. You cannot multiply by root of 3 over root of 3. Let's multiply it to see exactly what's going to happen, so know why we can't do it. So we'll have on the top 4 root of 3 divided by, and then we're going to have root of 3 into root of 3 plus 2. And obviously you're going to get 4 root of 3 divided by 3 by root 3 is just going to be 3, and then plus 2 root of 3. Aha. We are going to have this root 3 here still. That means we can't have it in the simplest form like that. So we're going to have to fix that again. Okay. So how do we get rid of it? Well, we use one of the rules that we already learned about all the way back when we were talking about quadratics. And that is this rule here. A squared minus b squared. A squared minus b squared is going to be equal to a plus b into a minus b. Right? So we have this here, a plus version. Right? And we have to multiply by this, a negative version. Once we multiply these two by each other, right? Once we multiply this by a form of this, we're going to get something here squared, something here squared. If we have a surd here and we square it, this is going to be a number, a whole number. Just like how when we did it over here and we had square root of 2 multiplied by square root of 2. 2 by 2 is 4, square root of that is just going to give me back the 2 inside of here. So we're going to use that principle and we're going to apply this to turn this around. All right, so let me just write that out. So I'm going to just take this and I'm going to bring it down here, right there. And I'm going to say 4 over 3 root of 3 plus 2. If we multiply by a convenient form of 1, what is the convenient form of 1 that we're going to multiply by? Root of 3 plus 1 and multiply by, 2. This is going to be root of 3 minus 2 all over root of 3 minus 2. So we're going to use this, as I said. Notice that this here becomes the square of each one. So once I have this, I'm going to have here that it's going to be equal to 4 into the root of 3 minus 2 divided by root of 3 squared minus 2 squared. Right? And this is going to be 4 root of 3 minus 4 2s are 8 divided by root 3 squared is just simply 3. 2 squared is 4, so minus 4. This is going to be minus 1, so I'm going to get something like 8 minus 4 root of 3. So the minus 1 causes the signs on the top to flip, right? And that's it. That's the simplified version of it, right? So that is the end of the lesson. Done right there. And what we can do now is we can solve some exercise problems so that we would be able to get some practice. And again, you can simply pause the video during the lesson and just solve it and then come back and play it and you'll get the solutions right away. 12 plus 2 root of 27 all over root of 3. So let's see if I can solve that now. Alright, so the first thing I want to do is I want to break up the top a little bit. Let's see if I can break it up into something that has the same kind of roots. And I'm seeing that both of them has a factor of 3, so I can just simply do something like this. I can say 3 root of 4 times 3 plus 2 root of 9 times 3. So I have something with root of 3 in both cases. And look underneath here, I have root of 3. Now the question is such that it will easily let you see what the factor is that you're going to have to factor out or pull out. Okay, and from there we can see that we can get 3 root of 3 root of, well, actually that's 2, so 3 2s are 6, right? So that's 6 root of 3, and then 3 here, this is 3, and that's 2, that's 6, so that is plus 6 root 3 all over root of 3, which is going to be 12 root of 3 divided by root of 3, and that is going to be 12. Right, let's go on to another one. And we're seeing that 2 root of 5 minus root of 2, close bracket, open bracket, 2 root of 5 plus root of 2. Again, this is difference of two squares right here, so you can just simply apply that. You can say this is going to be 2 root of 5 squared minus root of 2 squared. And that would just simply square the 2. It's going to square the 2, multiply by the 5, and then we're going to minus just the square of that. So we're going to have 4 by 5, which is 20, 20 minus 2, which is going to be 18. Right? Simple answers. Let's go to number 3. We have here 5 plus root of 7 all over 2 minus root of 3. Again, we're going to use these perfect squares principle. Sorry, the difference of two squares. My God, why do I keep saying perfect squares? Difference of two squares, right? So we're going to use the difference of two squares, and this here is going to be 5 plus root of 7 over 2 minus root of 3 multiplied by 2 plus root of 3 all over 2 plus root of 3, and we're going to get on the top we're going to get 5 times, well, 5 plus, not times, plus 5 plus root of 7 into 2 plus root of 3, and then divide that by 2 squared plus root of 3 squared, sorry, minus root of 3 squared. And let's expand it up. So 5 2s are 10, so I'm going to take this, multiply by this, take this, multiply by this. I'm going to get plus 5 root of 3, and I'm going to take this, multiply by that, and I'm going to get plus 2 root of 7. Take this, multiply by this on the end here, and I'm going to get plus root of 21 all over 2 squared is going to be 4 minus 3, root 3 squared is going to be 3, so that's 1. So then that means we're going to get here 10 plus 5 root of 3 plus 2 root of 7 plus root of 7 root of 7 root of 3, right? I'm wondering if I can actually simplify this and factor it. I don't know. Let's see. What I can do is I can find my calculator, which allows me to do this. Just give me a second, let me try and see if I can find it. That's drive and here, calculator. Alright, here we go. I will just simply type in this on the calculator and see if it is I can actually do. Right, so let's see if I can do that. So we can say 10 plus 5 root of 3 plus 2 root of 7, and then plus root of 7 root, oopsie, backspace that, root of 7 root of 3. And let's see what we get. Nope, it can't simplify. It gives me a decimal, can't simplify it. Right, so that's the answer there. I'll just minimize that. Right, so that's the answer there. Right. Let's see now. We're going to do another one. This one was 3. Let's go to number 4. Right, so number 4 is 2 root of 3 divided by 3 root of 2 minus root of 3. And again, we're going to multiply this by 3 root of 2 plus root of 3. divided by 3 root of 2 plus root of 3. And my handwriting is starting to get crappy. So we're saying 2 root of 3 into 3 root of 2 plus root of 3 close bracket divided by, let's see, this here is going to be 3 root of 2 squared minus open bracket root of 3 squared, and we're going to get that it's equivalent to 3 2s are 6 and then root 6. So we have here 6 root of 6 plus, let's see, that is 6 alone. So we're going to have 6 into that. We'll just factorize it afterwards. This one here squared is 3 3s are 9, by 2 is 18, and then minus 3. So this turns out to be 50. So we have 6 into root of 6 plus 1, close bracket, divided by 50. 3 into this is going to be 2, 3 into this is going to be 5, so we're going to have 2 root of 6 plus 1, close bracket, all over 5. Right, let's go on to another one, number 4. That's number 4, let's go to number 5. And this is my fifth example. So root of 8 plus root of 2, close bracket, squared, minus open bracket, root of 8 minus root of 2, close bracket, squared. We're going to square this. So this is going to be root of 8 squared, which is just simply going to be 8. Let me just start off. So this here is just going to be 8, starting on the first one. Then we're going, no, I'm just putting this here. A plus B squared is equal to a squared plus 2ab plus b squared. That times root of 16, right? You know what? Let me just expand this out slowly so you all can see. So root of 8 squared plus root of 2 times 2 times root of 8 plus root of 2 squared minus, and I'm just going to put this in a square bracket here, minus, same thing is going to be in the other bracket, similar thing, so I should say, root of 8 squared, and then we're going to have minus instead of a plus. It's going to be minus 2 root of 8 root of 2, and then plus root of 2 squared. Close the bracket off again. Right, and so root of 8 squared is just going to be simply 8. 8 by 2 is 16. Root of 16 is going, so 8 by 2 is 16. Root of 16 is 4. So 4 by 2 is 8. So we're going to have here plus 8. And then we're going to have plus root of 2 squared is just going to be 2. That's going to be in the first bracket. Minus second bracket. Root of 8 squared is just going to be 8. Root of 8 by root of 2 is going to be root of 16, which is 4. 4 by 2 is 8, negative 8. And then root of 2 squared is just going to be 2 plus 2. And then we're going to have 8 and 8, 16 plus 2 is 18, minus 8 minus 8 is 0 plus 2, minus a positive 2. And that is going to give me 16 as the end. So, right, let's go for the next one, 6. Alright, so let's say root of 6 plus root of 2, close bracket, into root of 6 minus root of 2, close bracket. And again, we're going to expand this out, difference of 2 squares. Notice that there, it's just going to be equal to root of 6 squared minus root of 2 squared. And then what we're going to have that is 6 minus 2, and that's 4. Simple, simple. 7. Let's see, that's 3 divided by root of 5 plus 2 divided by root of 20. Okay, well, from this, I can do the LCM, right? I can do LCM, which is root of 5, root of 20, or on the top here, we can have 3 root of 20, and then plus 2 root of 5. And root of 5 by root of 20 is root of 100. Root of 100 is 10. So this is going to be 3 root of 20 plus 2 root of 5 all over 10. Right? So I can write it in fractions if I wish to as well. Right? I wonder if I can factorize anything else there. It's looking like I can factor out a 4 by a 5. Yeah, I can bring that out. That could come down a little more. let's see. So this here is 3 root of 4 by 5 to give me 20, and plus 2 by root of 5 divided by 10. Let's see, that is 2 root 5. I have 2 root 5. 3 2s are 6. So that's 6 root of 5 plus 2 root of 5, which is just going to be 8 root of 5 actually. So 8 root 5 divided by 10. 2 into this is 4. 2 into this is 5. So we're going to have here 4 root of 5 over 10. Now at this point here, right, I would have said, hey, finish. And because I was in a rush, I wouldn't bother to do anything. Let's show you how to go about checking that. Now, earlier when I started using my calculator, I got a decimal for my answer. Let's see what we get here now. So my calculator is going to give me 3 root of 20 and then plus 2 root of 5, and down we get 10. And if I press equal, I'm supposed to get 4 root 5 over 5. Oopsie, yeah, this is 5 here. Right? But notice your calculator can actually do this calculation and check your answer for you. Right? So it's always good to try and see if you can get one of those calculators that can work out surds. If you can get a calculator that can work out surds, you have no errors when you're doing surds in future work. All right? Let's do number 8. Number 8 is going to be root of 18 minus root of 2 divided by root of 8. So I'm going to just simply first check and see if I have anything that can be written in terms of one factor, all of them having the same factor. Actually, you know what? Let me just rationalize this, right? I'm sure I can get the answer after I rationalize. All right, let's rationalize. So I'm going to take here root of 8 and multiply it by root of 18 minus root of 2 divided by root of 8 by root of 8 is just going to be 8. Okay, let's try and see if we can simplify the top a little bit. So we have 8 and we have 18. This here is just going to be 4 by 2. So I'm going to say 2 root of 2. And then that is 9 by 2 to give me 18. So I'm going to say root of 9 is 3. So I'm going to say 3 root of 2. And then minus root of 2, close bracket, all over here is 8. Okay, so that's working out nice. So I have root 2 by root 2 here, root 2 by root 2 here, and that'll just give me 2 to work with. So it's going to be 2 by 3 by root 2, which is just 2. And that's going to be 4 by 3, which is 12. And then root 2, which is just simply 2 minus 2 divided by 8. This is just simply 10 over 8. And this here will be 5 over 4. And that's my answer there. Right? Again, your calculator can actually do this. Right? Your calculator can actually do this. Let's look at it here. We can see fraction. We say root of 18 minus root of 2 divided by root of 8. And if I press my equal sign, I'll get 1. 1. Huh. I did something crazy, didn't I? I did something crazy. Let's see what we did. So root of 8, root of 8. This is 2, 4. How did I get 1? I would have to get 16 on the top. Let me just double check this. I'll do it over. Just because I'm not sure I made my mistake. Let's check and see. Let me just make sure that the calculator actually have the correct equation. I was checking 18 minus root of 2 over root of 8, and I'm getting 1. Okay, let's check that again. So, let's see. Root of 8 is going to be 4. It's going to be 4 by 2, right? This here is going to be 9 by 2 to give me 18. This here is root of 2, right? This here is 8. Okay, root 8 by root 8 is just going to be 8. Root of 4 is 2, 2 root 2. So I'm just going to get here 2 root of 2. And then root of 3 by 2 is just going to, root of 9 by 2 is just going to be 3 by root 2, 3 by root of 2, minus root of 2, close bracket. And then on the underneath here, I'm just going to have my 8 here again. I'm just going to cancel this 2 with this and leave me with 4, right? So I'll reduce that, and I will have here root of 2 into 3 root of 2. That's what I'm going to multiply by, minus root of 2 by root of 2. And then I'm going to divide that by 4. Okay. All right. So root of 2 by root of 2 is 2. So 3 by 2 is going to be 6. Ooh. See? 6. And then root of 2 by root of 2 is going to be 2. So it's minus 2 over 4. And this is going to be 4 over 4 equal 1. See? Using the calculator to check your answer, saved me a whole lot of trouble right there. All right. So don't hesitate to get a calculator that can do surds. Let's see. 2 plus root of 3 divided by 2 minus root of 3 plus 2 minus root of 3 all over 2 plus root of 3. Now, the good thing about it is here, difference of two squares appears twice. Right? Difference of two squares appears twice. You can see it right away. So you can just say that this here is going to be equal to 2 squared minus root of 3 squared. And the bottom is going to be the same thing. 2 squared minus, oopsie, hold on. This is not multiply, this is addition. Almost made a mistake. All right, let's go and do this again. So we're going to have here 2 squared minus root of 3 squared. That's the denominator. And this one here is going to be 2 plus root of 3 squared plus, and we're going to same thing, 2 minus root of 3 squared. And this top part here squared is going to be 4 plus 2 2s are 4 root 3. And then root 3 by root 3 is going to be 3. And then plus, put that in a bracket, plus, and then we say 2 2s are 4, and then minus 4 root 3, close bracket, well, not close bracket yet, and then root 3 by root 3 is plus 3 here. And then on the underneath, we're going to have here 2 2s are 4, minus root 3 by root 3 is root 3, so it's just going to be, it's just going to be 3, and that's going to be 1. So this here is going to be, well, it's plus, so everything here works out fine. So I can just remove this bracket here, because the plus will keep everything the same at the top and the second bracket. And then we have 4 plus the 4, 3 plus the 3. So that is 7 and 7, 14. And then these here will cancel with this here, so it gets rid of that. And then this here is going to be 1, so the answer is 14. Right, let's do another one, number 10, and this is the last one. Root of 3 plus root of 5 squared minus, open bracket, root of 3 minus root of 5, close bracket, squared. And let's do the expansion like we did in the previous one. So it's going to be root of 3 squared. You know what, let me just expand it slowly. So root of 3 squared plus 2 times root of 3 times root of 5 plus root of 5 squared. That's the first part, right? And it's going to minus off the second part. The second part is going to be root of 3 squared, and I'll just open that bracket up again, minus 2 root of 3 root of 5, and then we're going to have plus root of 5 squared. Close our bracket up. Alright, so let's simplify, and we can see that this here, first one is 3, then 5 by 3 is 15, by 2 is 30. Oopsie, it's going to be 2 root of 15. Right? Root 5 by root 5 is just going to be 5. That's that. I'm going to minus, open bracket, this is going to be 3, and then it's going to be minus 2 root of 15. Right? That's here. And then plus root 5 minus 5 here. Right? This second bracket, it's minus here. So this second bracket is just going to have everything reversed. So this is 3 minus 3 plus 2 root of 15 plus 2 root of 15, and then plus 5 minus 5. So this here is going to cancel off here. This here is going to cancel off here. So this came from this point. This came from this point. I just grouped them together as I was separating them. And then we're going to have here 4 root of 15. I have 5 and I have 3, and 5 by 3 is 15. I don't have any other products that I can reduce that with, so that's going to be my answer there. Alright? Okay, so that's it for this first lesson in surds. You now know, and you have a lot of experience now, how to simplify your surds down to its simplest answers. Alright? How to simplify your surds down to its simplest answers. I still believe that this answer here is a little bit too complicated. I'm wondering if it is that you can possibly use factorization to be able to separate them into groups. That's what I'm thinking right now. So like you can do factorization by grouping. I don't know. Let me double check that. So I'm going to just take a copy of this and see if I can use factorization by grouping on it. Right? It looks like you can use factorization by grouping. I'm not sure if you can use factorization by grouping, but I'm just going to test it out right now. And it's going to be embarrassing if it doesn't work out. Maybe, maybe not. Probably not. Okay, let's see. Let's group this one. Let's group this one. So I'm going to have here 5 into 2 plus, well, root of 3, close bracket. I see root of 7. Oh, yeah, plus root of 7. And we have 2 plus root of 3. Oh, yeah, nice. Oh, yeah, look, 2 plus root of 3, close bracket there. And then we have 5 plus root of 7. So that's a simpler form that you can have it in. Right? So let me just take this and pop this back in to where it was originally. Right? So I'm going to factorize here. Right? Control C. Let's factorize. Right? And put it in here. Control V. Okay. How about this? Right? There. Let's take this entirety of number 3. Control C. Bring it all the way down to the bottom. Okay. Put the number 3 there. Right? And then we can see factorizing. Factorizing. Why did I think that I can do factorization? Well, the reason I'm thinking that I can do factorization is because I see this product in the corner here, and I see that this here has the root 5 and the root 7 split. And then I'm looking at it over here, and I'm seeing that I have the 10 here as well. So I'm thinking here, 5 by 2 is 10. So that's out here. And then root 3 by root 7 is going to be 7 root 3. So you can see right away I have something out on the end here, which is 5 by 2. And I have something out on the end here, which is 7 by 2. That's why I'm thinking that I can factorize. Right? I was in a rush to finish and I didn't bother to look at it properly. Right? Plus 2 root of 7 plus root of 7 root of 3. And it should always, if you think something is like that, you should just try it. You don't lose anything by trying it. You spend a minute to see if you figure it out. You just try it. Right? If it works out great. Then if it doesn't work out, then okay, no problem. You just go and you continue what you're doing. Right? But always try it out first. Root of 3. And then we can have 2 plus root of 3 into 5 plus root of 7. Right? So that's much simpler to factorize form. Okay? All right, fine. That is it. This is the end of the lesson. And if it is that you have any questions, comments, issues, let me know and I will get back to you. I was asked to do plane geometry. I am not doing plane geometry yet. That is A-level stuff. It's not that I don't want to do A-level stuff, but you need to be very specific on what plane geometry you want me to do. Anyway, that's it. So I will see you in the next lesson. Bye-bye.